All right, now for some hard ones. What you're going to discover, this is practically the first section of calculus, right? And what you're going to discover is that we're already in the situation in calculus where the easy problems and the hard problems involve the exact same process. There'll just be different tricks. So you'll have to sort of like have in your quiver of arrows, you'll have to have a bunch of different sort of algebraic tricks and stuff to make them work, kind of like we did with earlier limits problems. And there's just another example of that where these are going to be nasty, but it's because the algebra is worse, not because the concept is worse. And that's going to be true throughout calculus. Once you learn the concept, it might be even pretty easy to execute on the simpler problems, but then the way they make the problems harder is just by making them a little bit longer, making you do half a page of algebra with like crazy fractions and stuff. That's the kind of things that mess you up. So you're going to get tons of practice reducing and all that kind of stuff. All right, so we've already seen how to do these. Now we're just going to execute, hopefully flawlessly. But as usual, we're aiming for delta x to cancel out. So if delta x doesn't cancel out at the bottom, we did something wrong. We know we need to go back. All right, so step number one, we're just going to do this term, which means we're plugging in delta x. Now what makes this one x plus delta x in for x here and also here? So what's going to make this one nastier is there's going to be more stuff to FOIL and more stuff to screw up. So x plus delta x squared minus 2 times x plus delta x. And we got to keep that plus 1 also. Then we have a minus sign, then we need the original f of x. So I'm going to put it in parentheses because I don't want to mess up this minus sign. X squared minus 2x plus 1 all over delta x. All right, so far so good. So hope I don't run out of room. As you'll see, these get gnarly in terms of the amount of space required. All right, x squared plus 2x delta x plus delta x squared. Now I got to distribute this. Negative 2x minus 2 delta x. You can see how long this is. Plus 1. Now, in these problems, there's always this minus f of x, right? So there's always a minus sign that has to be distributed here as well. So we get minus x squared. But actually, we kind of like it. Oh, negative times negative 2x is plus 2x. And then negative 1. But that's where the magic happens. You know, we want a lot of stuff to cancel out and go bye-bye. And that's why it's going to happen, is that negative sign right here is going to end up making that whole second half of the formula cancel out stuff from the first half. So right away I'm like, oh, x squared, negative x squared. Let's see, positive 2x, negative 2x, plus 1, minus 1. All right, so as usual, all the stuff from this term canceled out and also took out some of the stuff. All right, so everything we have upstairs now has a delta x in it. So the next step, as usual, is to factor out the delta x. So we'll get delta x. So from this term, we got 2x. Then we got a delta x left over from the delta x squared. Then we got a negative 2. Let's see, is that everything? Yep, over delta x. So now the magic happens, bam. Because those canceled out, we figure we must have done it right, because that's what always happens. And now once you cancel those, you can just plug in 0 for delta x. So it's going to work. And it's only left one place right now, which is right there. So if you plug in 0 for delta x, that just goes away. And you get 2x minus 2, which, if you already know a little bit about the power rule, is the correct derivative of that. All right, excellent. So you can see that was nastier. You just had to be careful to plug in x plus delta x every place you saw an x in the original, and then not screw up any minus signs. All right, now we're going to get into a few that are just really algebraically gnarly. It's one thing to be plugging in x plus delta x and then it foils out and stuff, but it's way worse when there's fractions involved. You'll see what I mean in a second here. But you know, you'll just use the same tricks you've always used in algebra, well, algebra 2 really in pre-calculus, which is if you have a couple of fractions with x's in the denominator, find a common denominator, and that's the number one trick. All right, so what is f of x plus delta x? Well, we just take this and plug it in for that x right there. So we get 1 over x plus delta x. All right, then we got a minus sign. Then we got f of x, which was just 1 over x. All this over delta x. All right, so now if you're looking at this, you might be thinking, there's no way this stuff's going to cancel because everything's in the denominator, so there's no way to get at it. Well, that's where the common denominator is going to come in handy. So if you go back to rational functions, the common denominator of this term right here and this term is just going to be x times x plus delta x. So if you look at this first term, what it's missing in the denominator is an x. It's already got the x plus delta x, but it's missing an x. So I got to multiply it top and bottom by x. And then this one right here is missing an x plus delta x. So I'm going to multiply it top and bottom by x plus delta x. If this doesn't look familiar, you should probably go back and check out the rational equations stuff with x in denominators video in Algebra 2 or pre-calculus, because you're going to end up doing this a lot in calculus. All right, so once we do that and multiply it out, we got limit as delta x approaches 0 of x over x times x plus delta x, and then minus x plus delta x over x times x plus delta x. And all this, of course, is over delta x. Now, so far, you're probably not impressed. Don't see why I did this. But now, because they have a common denominator, all these terms upstairs have the same denominator, so we can just combine them into one big fraction. So we got x minus x. Remember, this negative sign has to be distributed to both, so it's going to be a negative x and then a minus delta x. All over x times x plus delta x. This might be hard for you to follow, so I would suggest pausing the video and trying it yourself, because you just need to, it's almost like a muscle memory thing. The more you practice these, the better you'll get at them. And all that's over a delta x. All right, so here's where the magic happens. Check that out. The x minus x gives you nothing. So we're just left with negative delta x over all this junk over delta x. Well, how can I cancel my delta x's now? Yes, I can. This delta x cancels this delta x, and I'm just left with a negative 1 up there in the numerator. If you don't believe me, you could sort of treat this as a giant fraction being divided by delta x, which is the same as being multiplied by 1 over delta x. Anyway, delta x's cancel, and we get negative, so the limit as delta x approaches 0 of negative 1 over x times x plus delta x. So like I said, whenever, like the step after canceling the delta x's is always just to plug in. So now we're just going to plug in 0 for delta x, not for x, only for delta x. So negative 1, delta x just becomes 0, and we get x times x. So this is negative 1 over x squared. And that is our answer. And sure enough, that's what you get with the power rule, as you'll learn in the next chapter. All right, pretty exciting stuff. Man, this one's super nasty, so let's see how it goes. 1 over delta x might not seem that bad, except it's got a square root in it, which means we're going to have some stuff hidden behind square roots. Man, let's get started. So I think we're going to use common denominators and all kinds of stuff on this one, because we have both a fraction and a root, which means we'll probably need common denominator strategies and rationalization strategies. Okay, so f of x plus delta x, not too bad. 1 over square root of x plus delta x. Then we got to take away f of x, so minus 1 over square root of x. And all that's over delta x. So plugging in isn't the hard part on this one, and it often is not. What's hard is getting these things right. All right, so, man, I'm going to find a common denominator first, so of this numerator stuff. So what is the common denominator of all that? Well, it's just going to be root x times root x plus delta x. So that's going to be this first term needs a root x, so I multiply top and bottom by root x, and I get root x over root x times root x plus delta x. Subtract, and the second term needs a root x plus delta x. All right, and all that is still over delta x. So, sorry about the slowness of this. These are excruciating problems, believe me. When I tutor calculus, I'm just basically sitting there watching someone do algebra for an hour, or 2 hours as the case may be. All right, so you get the benefit. You get to watch me do algebra for an hour. All right, so limit as delta x approaches 0. I'm just going to, since these are two fractions with common denominators, I can now just combine the numerators. So delta x minus square root of x, sorry, that was root x, minus root x plus delta x over square root of x times square root of x plus delta x all over delta x. Oh man. Alright, so now as you can see, this thing hasn't really worked out that nice quite yet. But there's a trick for root problems when you want to simplify them, and that is multiply by the conjugate. And the conjugate is just basically the same numerator, but with a plus sign. So what I'm going to do is I'm going to multiply top and bottom of this fraction by square root, by root x plus square root of x plus delta x. And you'll see why I'm doing that in a second. Oh man, this is gnarly. Alright, I keep using the word gnarly. Alright, so what happens is when you multiply by the conjugate, when you FOIL this out, there won't be any middle term. So we'll just have root x times root x is x. Then we got a minus, and then we'll have x plus delta x. So when you multiply root x plus delta x times root x plus delta x, you just get x plus delta x. It's really important it's in parentheses because that means the x's are going to cancel. Alright, so that's like that. And then its denominator is now going to be x x root x plus delta x plus root x times x plus delta x. I know that's getting small, man. Alright, so what's great is that this cancels this, and I just got a negative delta x. So rewrite this, negative delta x. The x is canceled. Alright, so now I got a limit as delta x approaches 0. Sorry this problem is so long. Didn't really realize how long it would be when I wrote it. So now upstairs all we have is negative delta x. Oops, and under all this was a delta x from the original denominator, right here. Alright, so negative delta x upstairs of a crazy fraction. Then we got x root x plus delta x plus root x times x plus delta x. One's in root, one's not, all over delta x. Alright, now I was lost in the woods there for a while, but what ended up happening? That cancels that. So it's got a negative 1 over this thing. And of course, I don't know if this is indeterminate now or not, but it kind of can't be because there's no longer a delta x upstairs, so there's nowhere to plug in and get 0 for the numerator. Kind of complicated, but the point is that as soon as you cancel delta x's, you want to try plugging in 0 for delta x. So plug in 0 for this, it goes bye-bye. Plug in 0 right here, it goes bye-bye. So now I've got negative 1 upstairs. So just again, plugging in 0 for delta x's, I get 1 over x root x plus x root x, which equals negative 1 over 2x root x, because these are the same, so just combine them and put a 2 in front. Holy smokes, I can't believe we got there, but that is in fact the derivative of 1 over root x. Fantastic. Again, that'll take you about 2 seconds once you know the power rule. Alright, the last one we'll do. See if we can do this one a little bit faster. This is just cubed, so believe me, it's going to work out the same as they always do. You'll just get to see me FOIL out a lot of junk. Alright, so the first thing we got to do is plug in x plus delta x in right there. Whew. Alright, so we got x plus delta x cubed. Then we subtract f of x, which is x cubed. And all that's over delta x. Alright, so cubing that. First we'll FOIL 2 of them and leave 1. So we'll still have x plus delta x, but then we'll take 2 out of the 3 and FOIL them, and we'll get x squared plus 2x delta x plus delta x squared minus x cubed. Oh man, all over delta x. Alright, so this one's going to be the long line, I think. So let's see, we gotta start FOILing. So x times x squared is x cubed. X times that is that. X times that is x times delta x squared. Alright, now I gotta do delta x times everything, so I get plus x squared delta x. And I get plus 2x delta x squared, and then I get plus delta x cubed, And then we just got this guy in the end, minus x cubed, all over delta x. Do you believe me this is going to work out? I don't even know. I haven't done this one in a while. But I do notice that the x cubes cancel, so I feel like I'm doing some good here. All right, so now it's all about combining like terms. I don't know if there are any. So we got 2x squared delta x, and we got an x squared delta x, so that's a total of 3x squared delta x. Now my advice when you have a big mess like this, and it's going to happen a lot in calculus, is cross stuff out as you use it up. So 2x squared plus delta x, and x squared plus delta x gives us 3x squared delta x. So we cross them out. So now I got an x delta x squared. Got another one, so that's plus 3 x delta x squared. And then the only thing I haven't used up is plus delta x cubed. All over delta x, and of course this is still the limit as delta x approaches 0. Alright, so now what do I always do at this point? I factor out a delta x, because at this stage I should have a delta x in every term. So I'll factor out a, limit as delta x approaches 0. So I'm going to factor out a delta x. So we get 3x squared plus 3x delta x plus delta x squared all over delta x. Wow, they canceled out. That's great. That means I'm on the right track. Things are going well. And finally, as soon as I cross stuff out, I can plug in 0 now, right? So I can just take my delta x approaching 0 and plug it in for delta x. So that means I drop in a 0 right here. And this is also delta x, so I drop in a 0. Now again, I would encourage you, if you're in an AP class, freeze the video, try and work this out on your own. And then if you can't get it, go back and see what you did wrong based on my work. But it looks like I got this right, because if I plug in 0 for this term goes away. Plug in 0 for delta x here, that goes away. And I'm just left with 3x squared. So my answer is that f prime equals 3x squared. Same thing I would have gotten with the power rule. Alright, so that is awesome. My apologies for how gnarly a couple of these problems were, but if you're in an AP class or a college, like a hard college class going towards a technical degree, then you might see stuff that's nasty. But the same thing will always happen. You can always check your answer using the power rule, or something you'll learn in like the next section of the book. And you can also know that the delta x's always cancel out. So if they do not cancel, something went wrong in your algebra, you should backtrack and figure out what it was.